Hello, this is Sumit Khanna. Here we commence with a presentation on the case-based reasoning approach. Let me tell you that we shall not delve into the very rigor or the very mathematics or the technical jargon involved in the case-based reasoning. We will just present a basic overview on it so as to keep the things as lucid as possible. So, in a nutshell, case-based reasoning means using old experiences to understand and solve newer problems. Herein we remember a previous situation similar to the current one and use that to solve the new problem, or simply put, we use older cases to explain or critique or interpret a new solution. And here is the mapping that we use the older experiences and solve the new problem in this particular approach. So let us consider a paradigm for the CBR approach which I have devised on my own. Suppose we create a machine or a software M which gives prescription to the patients. Patients get to the machine, mention the symptoms as in what and how are they feeling. Let the machine know a couple of attributes about them, any persisting ailment for instance, or body saliences, for example high blood pressure, diabetes, etc. And machine M heeds to the patients, analyzes the gathered information, recalls previous cases and gives prescription to the patients. So this is a diagram, pictorial representation how it's going to work. Patients will be getting to the machine, describing the symptoms and other body saliences, and the machine converses with the data set. It recalls the previous cases and looks out for the similarities and then gives out prescription to the patients. Let us now have a glimpse at the mathematical representation of the problem. Suppose we have a set S, which is the symptom set, which includes elements of fever, vomiting or headache, and V is the body attribute set, which includes if a patient is already diabetic or age is less than 10 or skin allergies, and P is the prescription set where P includes prescriptions P1, P2, P3. We are keeping the number of elements per set very less, that is 3 almost, to maintain simplicity. And let X be the learnings from previous prescriptions, or better simply put, side effects, where X is P1 is equal to diabetic. As in, we here consider only one case, only one side effect, that P1 has a side effect on those people which are diabetic. Let capital D be a set containing D1, D2, D3. These be the instances or the previous cases which the machine shall be referring to while comparing for the newly arrived case, and such that D1 is the case where patient had fever and vomiting and age was less than 10 and was issued prescription P1, and D2 where the patient had symptoms of vomiting or headache and was diabetic as well, and we had issued him the prescription P2, and the third one wherein the patient experienced vomiting and headache, much similar to the symptoms experienced by D2, and he was skin allergic and we had issued him prescription P3. Let us recapitulate the previous cases quickly. In D1, the patient experienced fever and vomiting. His age was less than 10 and we had issued the prescription P1 to him. In D2, the patient experienced vomiting and headache and was diabetic as well, and we had issued him prescription P2. And in D3, we had a patient who experienced vomiting and headache and had some skin allergies as well, and we had issued him the prescription P3. We should remember the side effect set case where P1 is not recommended if the patient is diabetic. Let us consider the problem 1, wherein a fresh case C arrives in, where the patient experiences fever, vomiting, his age is less than 10 and he is diabetic as well. If you can see, the case C has much in similarities, has much in common with D1. Both have almost the same characteristics, but the only difference being that in case C the patient is diabetic as well. So as I mentioned, although the case C looks much like D1, we simply cannot issue prescription P1 to the patient just because of considering this as well, because P1 is not recommended for diabetic patients as we have learned it from the previous cases. So what we do is we go for an alternate solution which is approximate which is an approximate solution though. So what we do is we issue him the prescription P2, which we have learned from the dataset D2. As we can see, in the case D2, we had the patient experiencing vomiting and headache. We have in case C, the patient experiencing vomiting only besides fever. But what we can recall is that since in D2, if the patient is diabetic, as we can infer from the set D2, the patient was issued prescription P2, and we have a diabetic patient in case C as well. So the trade-off which we are neglecting or compromising with is that consequences of P2 on fever in case C have been ignored. Since we know the previous cases already, that is we have D1, D2 and D3 already in mind, let us consider another case, case 2, wherein C arrives in and patient experiences fever, vomiting as well as headache, and coming to the body saliences and attributes of that patient, his age is less than 10 and he has some skin allergies as well. So the solution we present to this particular case is rather a combination of both D1 and D3, because the symptom set of the case C is actually a union of symptom set of D1 and symptom set of D3. Also, the body attribute set of the case C is a union of the body attribute set of the problem D1 and the body attribute set of the case D3. So inferring from both cases D1 as well as D3, we issue the prescription P1 plus P3, that is both P1 as well as P3, and herein we have neglected any effects of P1 on skin allergies or any effects of P3 on patients with age less than 10, or any consequences of P1 and P3 when recommended together, that is any reactions or haphazard consequences they might lead to. So summarizing the case-based learning approach, herein the remembered cases are used to suggest a means of solving a new problem, suggesting an adapted or an approximate solution, to warn or know of the possible or potential failures, or interpret a solution. That is, if we seek to mine any inferences from the solution that we have suggested using this approach. So let me summarize it over in this way: that new case arrives, it converses with it contacts the previous cases, recalls the previous cases, and then as an output we may have a solution, an approximation over some of the attributes or solution or as a whole, or the predictions and the warnings that this particular approach might issue over a fixed domain or a problem, and interpret a solution, its attributes or the inferences which can be or which could be drawn from the solution post. Let us take a glance now at some of the thrust areas where CBR approach could be of immense impact. The first one being advocacy, wherein lawyers recall the previous cases and consider judgments or decisions of the jury over those cases and appropriately take a step ahead. The second one being grooming a child. CBR approach just couldn't get as naive as grooming a child for the world. Child observes the behavior of his peers or any new acquaintances, and in the next similar encounter, child recalls the previous experiences, and brainy and manipulative ones now know all tactics to confront the problem. Another promising arena could be establishing relations with different other nations for any country. Suppose we have a country A, it keeps along with it a record of experiences with nations B and C over various domains like trade, sports meet, e-commerce, or probably war or peace. And whenever new deals are proposed by country B or country C, which might also have their own records to refer to, the country A, after communicating with its own database, now knows whether it's a deal or not a deal, and sets one's own terms and conditions. Coming to the limitations in CBR approach, now let me tell you, this is entirely my observation over the case-based reasoning approach, so I cannot entirely vouch for its validity. But what I feel is that the machine needs to be replete with a plethora of data cases, enough outliers failing on different combinations of attributes in the instances to provide amicable solutions to the new problems. This means that the machine has to have a lot of data cases to refer to so as to come out with an amicable solution. So much so that there should be enough outliers or enough data cases where one attribute or the other fails or is not up to the mark, so that we can tackle the newer cases effectively. Secondly, there has to be a recorded problem. Since there has to be a recorded problem to almost resemble the current problem, such that if an entirely unique or a new problem arrives in, it should get processed very slowly and ineffectively. Thus, put differently, learning rates seems to be slow relatively, but it grows exponentially as the new cases keep adding on to the database. So this was my presentation on case-based reasoning approach. Thanks for watching.